So in the previous video I have explained regarding the Big Bang theory. So let's study about the Big Bang theory in the NCERT now. So the most popular argument regarding the origin of universe is the Big Bang theory, and also it is called as the expanding universe hypothesis theory. So Edwin Hubble in the 1920 provided the evidence that the universe is expanding, and as the time passes galaxies also move further and further apart, as I have explained, and linking the Doppler effect, Doppler redshift. I have explained this right in the previous video also, that by observing the redshift in the spectrum we can say that the universe is expanding and galaxies are moving away from the observing body. So you can experiment and find out by taking a balloon example. So take a balloon and mark some points on it to represent the galaxies. Now if you start filling the air, or if you start inflating this balloon, you can see that the points in the balloon itself will be appear to be moving away, right, and as from the each other, and as the balloon expands. So while we are inflating the balloon, we can observe that the points in the balloon are also expanding, right, and the points in the balloon on the balloon are moving away from the each other. So similarly the distance between the galaxies also found to be increasing, and thereby universe is considered to be expanding. However, there was a little issue with the balloon theory. What is that? The point itself will also getting expanding. That is not actually happening with the galaxies. So that is a minor issue with the balloon theory. So this is not in accordance with the fact of regarding the expansion of galaxies. So scientists believe that though the space between the galaxies is increasing, observations do not support that the expansion of galaxies itself. So galaxies itself are not expanding, but the space in between the two galaxies is increasing. Okay, so the balloon example is only partially correct. So the Big Bang theory considers the following stages in the development of universe. So in the beginning, all the matter that forming the universe existed in one place, that is called as the singularity, or the tiny ball or singular atom, with infinite volume of temperature and infinite density. So take this as a singularity or the single atom or the tiny ball. So after the Big Bang event, what happened? The tiny ball exploded violently, and this led to the huge amount of expansion. And it is generally accepted that the Big Bang took place 13.7 billion years ago from the present. Okay, and the expansion continues even to the present day also, and as it grew, some energy is getting converted into matter, that is quarks, right, as I have explained in the previous video, right. There was particularly rapid expansion within the fraction of a second after the bang, and thereafter the expansion has slowed down. Within the first 3 minutes itself only of the Big Bang event, the first atom began to be formed, right, as I have explained. So within some 3 lakh years from the Big Bang theory, temperature dropped to 4500 Kelvin and gave rise to the atomic matter, and the universe became transparent. So after getting to this much temperature, electrons are getting fused with the protons plus neutrons, forming the atomic matter. Okay, the expansion of universe means increase in the space between the galaxies, and alternative to this was the Hawley's concept of steady state. It states it considered the universe to be roughly the same at any point of time. However, with the greater evidence becoming available about the expanding theory or Big Bang theory, scientific community at present favors the argument of Big Bang theory only, or the expanding universe. So after the Big Bang theory, we specifically now understand how the star will be formed, formation of the star. Okay, right. So during the Big Bang theory, what happened? Universe has expanded, right, and the matter, that is gas and dust, become gravitation. Because of the gravitational energy, they started getting condensed and started forming the clumps, right, because of which stars will be formed, and more stars combined to form the billions of stars combined to form the galaxies, right, and these billions of stars, dust and the gas are bound together by the gravity. Okay, Okay, and these galaxies, various number of galaxies bringing together to form the universe, right? So that is the concept of universe and galaxy. So how specifically regarding the star formation or the origin of star? So when you see a galaxy, there will be a huge number of nebulas will be present, not just a single nebula, there will be huge number of nebulas will be there, and in each nebula there will be presence of hydrogen, helium, dust and various heavy materials will be there, right? Heavier elements will be there, and these clouds of hydrogen and dust gas, we can hear this can be called as a nebula, and there is huge amount of dust and various hydrogen and helium metals will be present in this nebula cloud. So once the collapse because of its own gravity happens inside this material itself, inside this nebula itself, we can see the formation of clumps, which are also called as the protostars. See, so because of the condensation here or because of the gravity here, we can see the formation of clumps, right? These clumps are also called as the protostars. So once the temperature inside these clumps or the protostars, right, reach to a certain level, there will be fusion of these hydrogen atoms will be happening, and once the hydrogen atoms fuse, there will be huge amount of energy will be released, right? That energy is called as the nuclear energy, and that's how the sun is also formed. So clumps contract, and the gravitational energy itself, the gravitational energy present in these clumps will be transformed to the heat energy. When this temperature in this clump, right, in the central part reaches the 10 million Kelvin, nuclear fusion will begins and hydrogen atom starts fusing into the helium, right? And that's how a new star has been formed. That's how the same sun has also been formed. Okay, right? So after the formation of sun, there will be the dust and gas present outside the sun also, outside orbits of the sun also, right? Once the central star has been formed, there will be remaining gas and dust will be present. That won't just disappear just like that after the formation of the sun. You can see in this image also, like this is all the gas and dust, right? This is the newly born sun. So after the sun has been formed, there will be spin in this particular nebula, right? So after that, what happens? Because of the spin, there will be flattened disk due to the conservation of angular momentum. So because of the decrease in the radius of the nebula, there will be more angular momentum, because of which the rotation of this particular nebula cloud will be more, because of which what happens? There will be a flattened disk will be formed around this sun, little sun. So because of which what happened? Dust and the particles which are present outside this sun will start collide and stick together, right? Because of the cohesion and electrostatic force, they will form the clumps, and these clumps again will grow in size and will become the, so see here the particles, gas and dust, they will form the, because of the electrostatic force and cohesion, they will start forming the clumps, and they will grow and become the planet simulals, which are rocky or icy building blocks, right? These are the planet simulals which are specifically rocks. Fine. So once these planet simulals which are formed, they will keep colliding, and the larger ones having more gravity, because of having more gravity, they will attract the more material towards them. See here also they are attracting more number of materials around them, and they will combine with these planet simulals by the process called as the accretion, and the planet simulals merge and forms the planets. That's how the planets has been formed. So once the planets has been formed, there will be solar wind coming from the sun, which will blow away the remaining gas and dust that are present, and after the blowing of that gas and dust, what will be the remaining is called as the planets. We can see from the sun, right? If this sun, we can see the first 4 inner planets, and the next gaseous planets, gaseous giants. So that's how the planets has been formed. Origin of stars and planets. So now we will read in the NCERT ones. Okay, so the distribution of matter and energy was not even in the early universe. So there will be density differences, right? And because of these density differences, there will be the different gravitational forces will be there, and it causes the matter that is present to be drawn together, because of which drawn together, and these formed the basis for the development of galaxies. A galaxy contains a large number of stars, and the galaxies spread over the vast distances that are measured in the light years. So the distance between the galaxies are measured in the light years, light years. Okay, the diameter of the individual galaxies, right? Individual galaxies range from 80,000 to 1,50,000 light years. A galaxy starts to form by the accumulation of hydrogen gas in the form of very large cloud called as the nebula. Eventually, growing nebula develops localized clumps of gases. This clumps continues to grow even into denser gaseous bodies, giving rise to the stars. That's what we have explained in the explanation part also. The formation of stars is believed to happen 5 to 6 billion years ago. Okay. So a light year, what is the meaning of light year? Is a measure of the distance, that is not the time but the distance. Light travels at a speed of 3 lakh kilometers per second. Considering this, the distances the light will travel in 1 year is taken to be the 1 light year. That this equals to 9.461 10 to the power of 12 kilometers. Okay, the mean distance between sun and the earth is somewhere around this much, and in terms of light years it is 8.31 minutes. So this is regarding the formation of galaxies and stars. Now we will read about the formation of planets. So the following are considered to be the stages in the development of planets. So the stars are the localized clumps of gas within a nebula. So this is the star which has been formed. We can say this is just a sun, and within the nebula this is the localized clumps of gas within a nebula. The gravitational force within the lumps lead to the formation of core to the gas cloud and a huge rotating disk of gas. So huge rotating gas disk will be formed and dust develops around this gas core. Okay, in the next stage what happens? The gas cloud will start getting condensed, and the matter around the core develops into the small rounded objects. These small rounded objects are what we calling them as the planetesimules, or the what is that, or the clumps, protoplanets or the clumps. Larger bodies start forming by collision, and the gravitational attraction causes the material to stick together, and the planetesimules are the large number of small bodies. In the final stage what happens? These large number of planetesimules accrete to form a few larger bodies in the form of planets. That's how the origin of planets has been happened. So that is regarding the formation of stars and planets. Thank you.